Today, I'd like to brief you on our radio testing up in Michigan during my onboarding the first week of June. This happened on June 3rd. Participants were Luke Stewart, myself, and Scott Billingsley. Just to orient everybody to where we're talking about, we're in northern or central northern Michigan, 27 miles northwest of Grand Rapids. Top right of your screen, you can see it was a very remote area, very lacking in urban area. So Luke had selected this site just to ensure that we had the minimal interference and isolated with the best canopy possibly. You can see in the lower right the picture of the drone footage of the canopy that we utilized to conduct these tests. So during the testing phase, we had 4 tests that we conducted. We did a point-to-point, and this emphasized the ground vegetation between 2 mobile nodes. Second, we did a 1-hop relay, which was a base station with a relay node that was suspended by paracord that was adjustable from shoulder level to 20 feet, just to get a read from the shoulder to canopy level. And this incorporated a mobile station as well. We did a point-to-point test. This was with the bunker cases. We did this to measure over a given known where we had normal range readings, how much the bunker cases increased range. And finally, we utilized a drone and a base station method, utilizing the drone as an advantage point for the antenna with a mobile relay station as well. All right, so the left side of your screen, the ATAC, we're running ATAC 4.31 sieve. And this is the first test where we did ground vegetation. You can see a picture of the ground vegetation to the right. It was pretty thick. The testing results came out to about 640 meters. Ground distance, the vegetation again was pretty thick and minimal elevation change. These again were with 2 mobile stations. The second test, we moved to a different location, and again utilizing the ground vegetation measurement is what we were really focused on. But if you see to the top right, we suspended using paracord, we suspended a goTenna at shoulder level, and this was adjustable again from shoulder level up into the canopy. You can see Luke and his mobile station method in the bottom right. During this test, you'll notice that there's 2 yellow indicators on the map. There was a little bit of low ground in between there and high ground at the final point, but this test came out to 843 meters, which is a pretty substantial test through there. We elevated the radio further into the canopy and then ended up with a decrease of range, likely because the nature of this particular area, the canopy starts fairly low, so elevating it higher places more vegetation in between both radios. But this resulted in 843 meters. This test was conducted with the bunker cases. You can see on the right 2 suspended bunker cases that were free from any obstruction or interference. And this test came out to about 981 meters, so just short of 1 kilometer, which is a pretty substantial increase, measured at just around 16% increases on this. The final test was on a drone. You can see on the right, Mavic Mini that Luke provided. We had a goTenna velcroed onto this thing, and we put it up to 400 feet above ground level to shoot through the canopy. You can see the distance measured at 2.15 kilometers. And this was what we noticed. Placing the drone and the goTenna above the canopy actually will decrease the vegetation in between and provided quite a bit further range. These are the key takeaways. Range, obviously vegetation in between 2 radios is going to increase or decrease, or it's going to decrease the range the more vegetation you have. Bunker case extended by 16% measured and observed during these tests. And elevating the goTenna into the canopy can potentially decrease the range depending on the type of canopy you're working with. Again, using the drone to decrease vegetation density by increasing the height worked fairly well during this test.